Hello everybody and welcome to this electrodynamics series. Today I am beginning a new topic called the integral calculus. But before that, let me introduce you uh, a little bit about the multivariable calculus. Uh, the topics uh, that I am going to give you a revision are the this single integral, double integral, triple integral. These are the topic. Let me revise before moving further. Okay, so we are going to do integration, right? Let's say we have this x and y axis, right? And we're gonna have this curve f of x. Now we'll take this 2 points, let's say x, and the other point is x plus delta x. If we take these let's say if we take this section out of here, so we are zooming this particular section of the curve, so it's gonna look like, yeah, it's gonna look like this. And we can just assume these are made up of this. Okay, yes, so we can just think this line which has a length let's say delta s, sorry, not x. So it is made up of this delta x, right, which is equal to this delta x, and this is the delta y. Now what we have to do is to calculate the okay, so we can also imagine that this particular point is a particular point of x, so we can just represent it by indices xi and xi plus delta xi. Okay, similarly this length is particular, the length is delta si, and this particular length is delta xi delta yi. So the length of the curve is gonna be, from the Pythagoras theorem we know that this is going to equal to be this number, and xi is right. One more thing that we can do is we can just factor out this delta xi, right? We can easily factor out this term, right? And we're gonna have this delta xi square will factor out, but we have this this root, so we will left with this delta xi, right? So what is the total length of this curve? Let's say this curve began at a point x equal to a, let's say, and ends with the point, let's say, x equal to b. So the total length, right, total length of the curve from a to b is actually the summation of all delta x si. We will just add up the length of all these small chunks that we can break this curve into. Okay, right? But of course this is a curve, so and this is a straight line. So how we will deal with this thing? So what we have to do, we have to just just compress this delta x into a very smaller size, right? So after that what we have to do, okay, so let's say I is running from, let's say, 1 to n, and for I equal to n we will end up this point b, and I equal to 1 we have this point here, this. So we can write over here x1 is equal to a, x let's say n is equal to b. Okay, now what next we have to do, we have to take the limit delta x I tends to 0. Okay, but before that, uh, this delta xi, I mean this delta xi is different for different locations. Like for this x, for this ith point we have this delta xi. For jth point maybe we have this delta xj. But let's just divide this curve into equal segment of this x-axis, right? So the for the first segment, I mean the first line, let's first draw this, then we are gonna understand it in better way. So we have this curve, so we divide. This is the x-axis, this is the delta x. Again we'll take the equal interval of this x, and this is again delta x, and this is again delta x, right? So we will do like this. So what we have, this delta xi will become only delta x, because all the ith you know, this ith ith number will have same this delta x, right? So we will have this delta x tends to 0. So as this delta x compresses, I mean these two lines will come closer to each other, right? So it is gonna will look like this. These lines will get closer and closer, right? So as it happens in this equation, there will be two changes we will observe. The first is that this integral, I mean this summation will become integral, and this is how we define the term integration. Okay, and this delta s will become ds. And here d itself mean that we are taking a very small values, and we have calculated that what is this delta s, right? And this delta s, and here by taking the limit delta x tends to 0, then this equation is will become 1 plus this limiting this delta x I in this equation will give the derivative of that function. Okay, and this will look like delta x dx. So we will left with this equation, 1 plus f prime of x plus dx. So this is so what integration does, it calculate the length of the curve in this case. Again yeah, so this is the case for the one dimension. We'll move on to the two I mean for the two dimension variable function, or we'll move to the two dimension cases, and in that case we will see the double integration. Okay,